So let's take a look at number 7 on the exam. It's asking us to arrange the following in order of increasing basicity. Now, for simplicity's sake, or for a little bit clarification, I was trying to ask you guys to look at, this group versus that group as separate ones. But some of you guys went through and arranged all 7 of them, which is fine. Either way would be a acceptable answer. But we'll just break these apart into group by group. So if we look at group number 1 there, what we are looking for is increasing basicity, right? So we need to find our weakest base first and then move our way up from there. Now, when we're looking at a base, right, we're going to be typically looking for things that have a negative charge on them. And if you take a look, let's put some numbers here. We'll put, or not numbers, but letters so that we don't confuse them. So if you look at compound D, we see that there's no charge on this one at all. It's a neutral molecule as opposed to A, B, and C, where we have negative charges all sitting on oxygens. So it'd be a very good assumption to make that compound D over here would be the weakest, right? So we'll start with weakest equals 1, right? And we'll move our way up from there to the strongest. So no negative charge, right? That's going to be a very weak base then. If we take a look at our other 3 molecules here, we have A, B, and C. They all share in common that they have a negative charge on an oxygen. If we take a look at A and B, the difference between them there is that they are going to have a resonance structure along with that negative chlorine there that's helping to stabilize that minus charge through inductive effects. So if we go through and we make a list, we've got inductive, we've got resonance, and resonance here. Whereas with compound C, we have none of those, right? We don't have any resonance, we don't have any inductive effects. So for a strong base, you want a localized negative charge. Anytime you have inductive or resonance effect, we're going to delocalize that charge. If you delocalize a charge, you make a weaker base. And so our strongest base then is going to be one that has a very localized negative charge. So we'll put that one there as the strongest base. Then in between A and B, we have inductive versus resonance, right? That inductive effect is helping to delocalize the negative charge a little bit more. So this will be our second weakest base, and this will be our third right there. So we looked for charge, we looked for inductive effect, we looked for resonance, and we made a list and we kind of went through our checklist with that. Now we can go through group 2 here and kind of make a similar list, examine what's the same and what's different. Right here we have a nitrogen with a -1 charge. We have an oxygen here with a -1 charge. Oxygen here with a -1 charge. So remember, if we're in the same period in the table, in the periodic table, electronegativity is going to dominate rather than radius. So by just looking at the charges here, we see that a nitrogen with a 1- charge versus an oxygen with 1- charge, the nitrogen is going to be a more localized negative charge there, right? The electronegativity of that nitrogen is going to be more negative in a certain way, right? It's going to be more negative. So this is going to be our strongest base here because that nitrogen can't handle that negative charge as well as the 2 oxygens can. If we take a look at the other 2 oxygens, here we have resonance as opposed to in our hydroxide molecule where we don't have any stabilizing. And so we make the choice between a resonance structure delocalizing the charge versus just a simple oxygen with a negative charge. So the more delocalized the charge, the weaker the base is going to be. So we would say that's the weakest base. That's the second strongest base. And there's our answer for that first part.